I'm Ted Horbulyk. I'm an economist. I'm a visiting fellow here. Today I want to talk about a problem which is complex, it's messy, it's got many dimensions, and as a result, people sometimes, agencies, groups find it hard to know where to start, how to start. They use this as a reason for not wanting to cooperate. The particular problem is contamination of our groundwater from nitrates. Okay, this is due to agricultural activities generally, but caused by other human activities, and it can cause health problems and problems to the environment. The specific locations that I'm working on as a project with myself and a student are Southern Ontario and also the lower mainland of British Columbia. So the Abbotsford Aquifer might be well known to you, and of course, and this makes it a transnational problem because in the case of Abbotsford, Canadian agriculture is contaminating groundwater which is flowing into the U.S. This is causing some tensions and a need to cooperate to try and solve this problem. So in some sense, this might be an easy problem to solve because when you contaminate the groundwater, you don't actually have to, with nitrates, because it's water soluble, you don't have to actually go in and take it out. If you have the luxury of time, you can just wait for it to wash itself through. So all you have to do is stop putting more in. They get 1.5 meters of rainfall every year there, and they irrigate on top of that. So if you just wait, it'll sort of wash its way through. So you'd think it'd be pretty easy. Just stop putting nitrate in, and the problem will clean up. Not quite so simple. It's hard to know because it's groundwater where it's going, how long it takes to go. The water table goes up and down. How far is it the water table? How long does it take the nitrate to get there and move forward? Whose fault is it? Where will actions work, and so on. So it's a tough problem. And as a result, some solutions which have been proposed are quite expensive and high cost, and people have put up their hands saying, we're not going to do that, this makes no sense. But if you take it apart piece by piece, and that's what this research is doing, you can actually show some plans that are workable and say, okay, maybe there's a basis for doing this. So what's the research about? Well, we're trying to be strategic at finding a cost-effective way to get this problem solved. We're using lots of physical research from the physical scientists, hydrogeologists, who have learned where the water comes from, where it goes, how long it takes. So, for example, there's a number of different towns that have their drinking water supplies from wells. You say, well, for these wells, a lot of the water that's coming towards them is already in transit, and it's going to be coming no matter what, but there's other areas where if we make some changes now, in the next 5 years, those will be filled. A lot of spatial and temporal dimensions to this problem. Where do we act? How quickly do we act? What are the costs? We take all this information in a series of menus that have cost attached and use mathematical reasoning and kind of a calculation to figure out what the optimal plan looks like. But that's just a starting point. Then you say, well, how do we actually get people to do this? And if you owned it all yourself, you say, okay, well, the plan says I should start here, do this, and then do this. Meanwhile, that will have happened. But when there's all kinds of private landowners, it's not so simple. Some municipalities, like in Southern Ontario, bought a whole bunch of the farms and said, we're going to run them the way they should be run, and we'll rent them out to farmers who want to cooperate. In other cases, you can think about subsidies and encouragement and fines and enforcement and monitoring and conservation easements and all kinds of strategies. And so then the second part of the research is saying, how effective will these things be? What do they cost? How quickly will they act? Will people do these things? And so from first having a plan and then saying, okay, what are the tools and mechanisms that we can get the right kinds of governance, we can help to solve the problem. The neat part is that if you get the solution, places like Abbotsford will have a sustainable source of drinking water. Without the solution, what they're currently considering is bringing a pipeline of water from far across the river, some jurisdiction which is elsewhere, and saying that maybe that could be our water supply. And the answer is saying, no, let's have another look. I think we might be able to solve this one.